Okay, before we get started on the sheet, let's just summarize what we have here. We have series circuits, which the resistors are one after another, and you have to remember the electrons don't disappear. So if you got 25 electrons coming here, they'll pass that one. The same 25 will pass that one and continue down the wire. So in series circuits, you can say current is the same in each one. And electrons return to the battery with zero energy. They give up all their energy when they go through the circuit. So say this guy had 10 volts or 10 joules per coulomb, it would give up, say, 6 here, another 4 there. It gives me a total of 10. Lost all its energy, goes back to the battery and gets charged up again. It comes around the circuit. So that leads you to this statement: voltage is split between the resistors. If I get 10 volts, these guys will add up to 10. It can be 1 and 9, 2 and 8, whatever it works out to be. Parallel, exactly the opposite's going to happen here. It's a different type of circuit here. Same thing, electrons don't disappear. So if I got 10 electrons coming down here, some are going to go that way, some are going to go that way, and they're going to join up and become 10 again. So it could be 6 and 4, 3 and 7. Grade 9, it was always 5 and 5. So in that case, the current is split between the resistors. So if you got 10 amps, 5 go this way, 5 are going to go that way. And then they join together again and continue around the circuit. This one says electrons return to the battery with zero energy. So if this guy had 10 volts or 10 joules per coulomb, every electron going this way will give up all 10 with nothing left and continue on back to the battery. Or the ones that go this way will give up their 10 and go back to the battery. Okay, so voltage is actually the energy for each electron. It's not a total. Okay, so you could have like one 9-volt battery and have 5 light bulbs that are all getting 9 volts. I guess take a look at the first circuit here. We got 4 amps coming out of here. So amps is actually the best one because they don't disappear. 4 amps are around that corner, and they're telling me 1 amp took the bottom. So if 1 goes that way, that means 3 amps are taking the top trail. And then the 3 and the 1 join together again to become 4 amps. Okay, so then we're working our way around that way. So 4 amps splits up 3 and 1. Back together is 4, and then back to the battery again. So then we got the amps for everything. Like number 1 is 3 amps, 1 amp, and this guy is 4 amps again, and the battery's 4. Okay, so it's always the same 4 going around and around. The source is 6 volts. R1, don't give it to this. This one is 1 amp, 1 amp's given. This guy here is 3 volts. Okay, so we will look at this guy. It comes out with 6. No matter which way he goes through here, plus this 3 adds up to 6. So this guy here would have to be 3 volts, because 3 plus 3 is 6. And the guys that go down here, they would be also 3 volts, because then 3 plus 3 is 6. So everybody's 3 volts. Okay, you can't just add them up. You can't say 3 plus 3, because if you look at one electron, it can only go one trail at a time. So this 3 plus that 3 is 6. Or the guys that go this way, that 3 plus that 3 is 6. And I guess we should have put Ohm's law up here. The old grade 9 triangle stuff. V equals IR. So if you have 2 numbers, you can get the other one right away. So R would just be V divided by I. So 3 divided by 3 is 1. 3 divided by 1 is 3. 3 divided by 4 is 3/4. And 6 divided by 4 is 1.5. Or 6/4. I don't know. 3/2. So you can put down 1.5 if you want. Okay, let's take a look at the next one. Okay, you can also group these guys. Like this here is one big parallel part. But let's take a look at it. 10 volts. This guy's 4 volts. This one's in parallel to it. The voltage will be the same, so this one will also be 4 volts. Okay, we do information for 3. It's 4 volts, 1 amp. R is V over I. 4 divided by 1 is 4. So you got those numbers already. These are both 4 and 4. So that's number 2. It's 2 ohms. And it's 4 volts. Hold on a second. It's 4 ohms. 2, 4. Okay, 4 divided by 4 is 1 amp. So these guys are exactly identical. 10 volts come out. No matter which way I go through here, it's a 4 volt drop. Okay, so when I lose 4 here, I have to be losing 6 volts there. Okay, because 6 volts, this is a total of 10. 6 volts here, plus 4, no matter which way you go through here. If I go this way, it's a 4. If I go through the outside trail, it's a 4. And they split up equally. 1 goes this way, and 1 amp goes that way. So if I got 1 car driving down this road and 1 car driving down that road, and they join together onto 1 road, there's going to be 2 of them going through there. And the same 2 will be driving by that guy. So he'll also be 2. And then you get the resistance. 6 divided by 2 is 3. 10 divided by 5. Okay, you could also do the group thing here. 1 over 4 plus 1 over 4 equals 2 over 4. Okay, but that's 1 over R total. So now I have to flip that. It's 2 ohms. Okay, so you could add them up. This one was 3 ohms. 3 plus 2 for the whole group is 5. I think 10 divided by 5 is much easier. Whenever you have the 2 numbers, go straight to the Ohm's law. Okay, here's now the circuit. Now these guys here, these ones are in series. Okay, I got 12 volts. Some electrons are going to come through here. They get to this point, it's a decision. Some can go down here. Some are going to travel through this section here. Okay, so, and then we can look at the voltage. So we got parallel parts, and we have a series part here. But this guy's connected directly to the battery. So any electron that takes this trail has to lose all its energy and come back. So this would be 12 volts. Sure, we can fill that in. R1 is 12 volts. R is 4. Total is 12 volts coming out of here. And these guys are 4 and 2. This is series. It's just 6 ohms. 4 plus 2 is 6. That's the thing for the whole group. This part is connected directly to the battery. So this whole bubble section will also get 12 volts. As soon as you get 2 numbers, go straight to the triangle. So 12 divided by 6 is 2. So this will be 2 amps in this whole package. So now I know that, well, we can get this one. 12 divided by 4 is 3 amps. So I know 3 amps are taking a hike down that trail. I know 2 amps are going that way. So 3 go that way, 2 go that way. That must be a total of 5 amps coming around this whole circuit. And the voltage for this section, well, it's 12 volts for the whole thing. We got 2 amps going through. Now we know in series, the current's the same everywhere. So this will be a 2 amp, and this will be 2 amps. Okay, before we try to figure out the voltages by ratios and all that, we have the 2 numbers now. V equals IR. So 2 times 4 is 8. 2 times 2 is 4. So let's check out the circuit then. Here comes an electron. Yeah, I got 12 volts of energy. If it goes this way, loses all 12, comes back with nothing. If it goes this way, we figure this was 8 and 4 volts. 8 plus 4 is 12, come back with nothing. So that trail works. The current never disappears. We have 5, it splits into 3 and 2, comes back together as 5. So everything works out for that circuit. Now let's take a look at this next one here. So we have a nice parallel part here, another parallel part there, and then a guy by itself. Well, we have the current. The current's the best help. Okay, there's 10 groups of electrons, 10 coulombs. They come to this here, it's equal. There's 8 ohms of resistance that way, 8 ohms that way. They'll split up perfectly. So I can write down here 5 amps already, another 5 amps there, and then they come back here as 10 amps. Now these guys are going to split up in a 2 to 4 ratio or 1 to 2 ratio. Splits it up 3 ways. 10 doesn't divide by 3 very well. So you could group this together, whatever you want. Let's go back to this guy. He's 10 amps there. He's 10 amps because the whole party's going through. These two are 5 each. This is going to split up into some weird ratio, but we can look at it differently. Let's get the voltages then. 5 times 8. That's an easy one. I should have put them in. These are 8 and 8. Whenever you get two numbers, V equals IR. 5 times 8 is 40. These are both 40 volts. Okay, both the same, because no matter which way I go, I'll lose 40, and then I'll come over here. 2/3 times 10. That's going to be 6.66 volts. R3. No, it's not R3. R5. It's 2/3. And it'll be 6.67 volts. And let's see what we got here. Now this group here, if I want to find the overall resistance, it's 1/2 plus 1/4, which is going to equal 3/4. But that's 1/R. So to get the whole resistance, R here will equal 4/3. 4 divided by 3 is 1.3. So if I have the resistance here of the whole package, and so now I have R and I have I can find V. V equals IR. So the 1.33 times 10 is 13.3. No matter which way the electrons go, because in parallel, the voltage is the same. So this would be 13.3. This would be 13.3, repeat forever, volts. It's on my screen, so we want to find I equals V over R. So 13.3 divided by 2, 6.66 for this guy. That's 3, 6.6, repeat. And that one, divided by 4, is 3.3, repeat. And the voltage was 13.3. And the resistance was actually given. There's 4 and 2. No, that's backwards. That's number 3. So that's a 2. And that's a 4. Okay. I think we're all good here then. And take a look at the numbers. Well, I have 6.6 amps here and 3.3 amps there. That's a repeating decimal spot though. So 6.6 plus 3.3 is 10. So we're back together again here. If I take a look at the current, twice as many went this way than that way, because this resistance is twice as easy as that one. So more will go this way. If we had like 3 arrows coming down here, okay, one of the arrows would go through this way because it's difficult, and 2 arrows would go that way. It splits up into a nice ratio. Unfortunately, 10 doesn't divide by 3 very well. And then the total, we'd have to find the voltages. So we got 6.6 volts, this one's 13.3, this is 40. So if I go 13.33333, 6.66666 plus that, plus 40, is 59.9999, so it's 60 volts. Okay, R is voltage divided by I, so that's 6 ohms. You could also do around the circuit, because this is an 8 and an 8, so that would be 4 ohms in total. 1/8 plus 1/8 is 2/8. Flip it back over again, we get 4. So 4 plus 4/3 plus 2/3. Let's see what that gives me. So 4 over 3. That's 1.33 plus 0.66666 is 2 plus 4 is 6. That's how you get the resistance the hard way. You could add them all up. But if you ever get the 2 numbers, just go straight to that one. Okay, one more to go. So we got 10 volts in total. So any electron leaving here will have 10 volts. Oh, they give you 2 numbers right away here. So I get V. V equals IR. 2 times 3 is 6 volts. Okay, so the electrons that come down this trail and the ones that go this way, they all start with 10. This guy's going to lose all 10 at once, so he's going to be 10 volts. I got 2 numbers already, so I can fill them in. 10, 2, volts is totals 10. resistor 1 is 2 ohms, 3 amps. And we got 6 volts right away because we just multiplied it. This one I can get the current. I equals V over R. 10 divided by 2 is 5 amps. So now I know that there's 5 amps going this way. We got 3 going down there. So I got 3 coming this way and 5 coming along here. That'll give me a total of 8 amps through the battery. Okay, I got 2 numbers right away. I can get R. V over I. 10 divided by 8 is 1.25. And let's go this way. Down this trail. So we got these 2 guys. They don't even give me the actual numbers. They just tell me that this one is twice as hard as that one. So that means that 1 group of electrons will go this way and 2 will go that way because it's a lot easier than that way. It's 3 amps is great. That splits up perfectly. So that means that 1 amp will go this way and 2 amps will go that way, just looking at the ratio. So R2 is 2 amps, and that guy is 1 amp. Okay, and the battery, we look here, we got 10 volts. All the electrons go through here and they lose 6 volts. So all the electrons entering this parallel part are carrying 4 joules of energy, or 4 volts, which means this one would lose 4 volts because this is a parallel. Parallel, the voltages are the same. So 4 come in, 4 go this way. So they're both 4 volts. R equals V over I. 4 divided by 2 is 2. 4 divided by 4 is 4. And look, 4 is twice as big as 2. Okay. And then we're all done this one.